Oh, technology. I always complain about technology. It's my lead-in. Hello, YouTube. How are you? Ben isn't with us right at the moment, but I have a special guest, Adrian Black from Adrian's Digital Basement. So,
Yeah,
hey,
hello,
Adrian,
everyone.
how are you?
I am amazing. Thank you very much for the intro.
Wait, I should say, why are you, right? Why are you doing all this retro stuff? What made you one day crack open one of these things and work on it?
It's a funny story. I think if people who watch my channel go back, I was using computers when I was 7, right? I got a VIC-20, and I really got a little taste for technology there. I was writing basic programs, but all through my young years, I was just continuing to use stuff, Apple IIs, whatever. But then, technology marched on. I remember back in the day, at least for me, I'm like, oh, this old stuff is junk. Let me just get rid of it. I'll get modern computers.
Right.
Then we get old and we start to think back to how fun and great things were when we were kids. And
when we had hair.
Well, there's that. Yes, absolutely. But I mean, I feel that technology now is commoditized, it's democratized, everyone had to use it, smartphones and all that kind of stuff. But it was different in the old days. You had to really explore and figure out how things worked, especially for young people like me. It wasn't we had the internet. So all that fun stuff existed, and in my adulthood, I was like, oh, maybe it'd be kind of fun to play around with some of that stuff. And all those things which you didn't have when you were a kid because you only had one computer, for instance, I was suddenly able to have all these computers, which I never had access to before. And I think that for me was super fun.
And they're cheap.
And they're cheap. Well, not anymore, but
right.
Years ago they were. Everyone was throwing them away.
They were truly cheap, yeah.
But I think the thing is for me is it's so hard to keep this crap running because everything is breaking all the time.
Yes.
So if I didn't figure out how to fix stuff, then I would have a bunch of broken old computers as opposed to ones that worked and I could play with and have fun with. So that's really what got me into trying to play around with this hardware and be able to repair stuff, because it was simply to keep my old computers that I started collecting running.
Okay. And you and I were talking before the show. I wouldn't turn on computers because I was afraid. I'd know they'd be broken. Why do I need to prove it? Matter of fact, if I don't turn it on, it might work or might not, right? And I saw all these things work almost 40 years ago, like the LCD computer behind me. I knew it worked, right? I didn't need to see it working again, but then I got inspired by you. I have to say, you were diving right into these things. As we were saying, I didn't want to fix it because I thought it'd be broken, and you jumped into it because you knew they were broken, right? Let's fix it. Of course, you have parts too, right?
It really helps. And obviously, I get emails from viewers and people, and they're like, hey, I have a Commodore 64. I only have one, and it's doing this. It's like black screen. Like, what should I look at? Right? It's like, well, unfortunately, there are ways to try to troubleshoot to figure out what the fault is, but a lot of times you at least need to have a few replacement parts on hand, especially like the PLA and stuff like that. So it can be hard. So yes, having access like I do now to so many repair parts is so helpful. But at the beginning, when I started fooling around with this stuff, like at the early stages of my YouTube channel, I didn't have viewer donations and I didn't have access to this stuff. It was just what I could find on local marketplaces, Craigslist kind of
eBay.
Thing.
Yeah,
exactly. And I never actually went to eBay because even there the prices were just out of hand. But
and in danger, you don't know what you're getting too,
and you don't know where they're getting. You're like paying top dollar for something that's like worked when I put it away, which is their favorite thing to say. And it's like, 30 years ago it worked. That doesn't mean it's going to work anymore.
The actual metal ions moved and migrated during that time. Yes,
I mean I kid you not that I've had I get chips like spares. I had like some spare SID chips. I will test them. I make sure they work perfectly, and then I'll put them away in anti-static foam in a bag and everything. And then a year later, I'll take them out, and like 2 have died in that time.
Yes, yeah,
just like okay,
especially Micron DRAMs. I knew the reason why. I mean, I knew the I don't want to say metallurgical reason, but I knew the chemical reason why they died. And now I don't. And that's part of being old. I go to open the door where I stored that information, and there's just some cobwebs in there now and stuff. But you mentioned the internet. See, I give my age away a lot of times, first off, when I show data books, but the fact I say the word data book instead of data sheet is kind of an indication of my age, because nowadays everything's data sheets because you research it on the internet.
I would
And
imagine, Bill, when you were like working on design work back in the day, you had those
piles
books
of
on your
books.
desk. And you would be like flipping through the pages. I need this one. Let me find out about this one chip I need, right? And then how did that work? How did you get to decide on what parts you used?
I'm known for having about 600 data books that I still have. I mean, I just went and grabbed my old hardbound transistor one. But the trick was, you would actually at night or something, you would look through your data books, and what you're doing is refreshing the memory, because the whole trick was, when you do go to do a problem, you go, oh, it's in this phase XR phase lock loop book, it's or this book or that book. And you have to remember to go which 5 data books to go pull and look through again to find it. You may not remember the page number, but you remember the book that it was in. Yeah. But yeah, it was from your mind. And so that a good memory, as opposed to being a good researcher, made you a good engineer back then. So yeah.
Even now, obviously, you still have to have like that fundamental knowledge, because yet while you can Google all those sheets so easily, you still need to know what you're looking for, right? You can't just read every data sheet. But so there is a lot of what you're talking about, like having that up in your head. So you're like, okay, I can use that and that and that, put them together and get the circuit that I need out of it.
Right. Hang on a second, since we're talking.
I'm reading the comments here.
If you see any worth there's Andre. Let's punch him up. Hey, Andre, how you doing? It's the 80s. Yeah, it is the 80s all over again. I learned so much because I'm a high school dropout, and I ended up getting my VOTEC schooling for TV repair. And then I got my TV repair license before I was 18. So I was actually a certified repairman, before the... But I learned, I got my break as an associate design engineer because I used to read these analog books by National, forwards, back. And the guy asked me a question that was on page 201, right? The bias currents have to be equal for temperature compensation to work in an op amp. And I remembered that. And the guy looked at me funny and started asking more questions. And that was it. My education started in the books. But then when I got in an engineering lab with brilliant people, I realized, oh, now the education starts. And I worked with some brilliant people. I mean, they just, they think in terms of computers, and you can, and chip designers. I found that when I would go in a chip designer's office, I'd start thinking in terms of admittance instead of resistance. I would change my thinking to how the FET guys, the FET guys thought. And it is amazing education. How did you learn repair?
Okay, so it's really funny. I didn't even graduate college. I did graduate high school, but I have absolutely zero training in electronics of any kind. The most I ever did is in college. I was computer science, so software stuff. But my roommate was a electrical engineer in training, right? He's getting his degree. And I remember crashing some of his labs. I was like, let me go to the labs with you. And I got to play around with oscilloscopes, and the teachers didn't mind that I was in there. So I did a little bit of that, but that was literally it. Like, I have everything that I do now. And I know people are asking this as a question. They always want to know like how I got into this. Right. It was like truly YouTube. It was seriously YouTube. Like, I would watch Dave Jones, the EV blog.
Right.
Just start to pick stuff up on other YouTubers as well, like making this electrical engineering stuff. And I'm like, wow, this is kind of cool. And that was back in the day, like before I was even touching retro computers. And then, like I said, I started buying these retro computers and going, oh crap, this stuff breaks all the time. What I have always been really good at, Bill, and this is, I'd say these types of skills are universal no matter what you're doing, is problem solving. So back in high school, I used to work at a computer store, obviously not doing circuit level stuff, but, fixing computers. So you need that troubleshooting skill set to figure out what component needs to be replaced and stuff. And it's rudimentary, obviously, but there is really no difference between working on a motherboard than trying to fix your car or anything else, where you have to think logically about what's wrong. And that's sort of my motto, right? There's a couple schools of thought for fixing computers. And I know you've seen this and everyone else has. You can be like, well, I'm just going to start replacing chips. Let's just start
Right.
swapping things out and like hope to hit the right thing. And that's what recapping to me is very much that. Like, oh, this power supply doesn't work. Let's just recap the whole thing and hope it fixes it. And it
And
might
hope you do everything perfectly, or you'll make another problem.
make it worse. And I mean,
Right.
I have fixed many a computer, Commodore 64s especially, because I fixed so many that so like someone has tried to repair it before by just like willy-nilly socketing chips and there's busted traces and nothing's ever going to work
Right.
from a plumber and a flowerist. Yeah, I mean, it's absolutely, it's all about logical thinking and
Localization of the problem. Is the problem to my left, to my right? Sometimes when it's a loop, and I've heard you talk about that because you work on CRTs, and the whole CRT is a horizontal oscillator loop.
yep,
You got to break the loop, but knowing which direction, or at least picking a direction and going, is part of it.
Well, it's funny because CRTs is something I've only recently started working on, only
Okay.
because I love them and I want them to work, and they break all the time, right? You know,
Yes,
'cause
they're old.
they're old and they're wearing out and they're gonna all die eventually. But needless to say, a CRT to me, especially like one like this Commodore 1084 here, very easy to fix because there's really only a few fundamental areas: the horizontal, vertical, you know, the high voltage. There's the B plus. There's
Right.
the video circuitry, the cathode drive. You know, there's not that much going on. And like you just look at the problem, you're like, well, I have a line in the middle of the screen. Okay, well, right away you know it's vertical deflection. That's
Right.
what you got to focus on. Don't even bother looking at that other stuff. It's
Right.
not the video circuitry, it's the deflection for the vertical. And that circuitry is usually all together on the motherboard, even if you don't
Right.
have the.
Right.
So, anyways, it's all about that. Just use your brain. And with the recapping or anything else, like it's just like, well, let's try to dig down into what exactly is wrong
Right.
and figure that out. And I have a very good friend, Frank IZ8 DWF. He's in Italy. He's an engineer from the 80s, electronics engineer, and he has helped me immeasurably because we chat all the time, and he loves that fixing thing that I'm talking about, where you figure out what's
Right.
wrong. And he taught me. Don't just replace things. Try to figure out where you can prove what's wrong, and
Right.
then the repair just comes naturally after that. And that's the motto I try to do now.
And we're known for, oh, did it really fix it? Let me break it again and fix it again. Okay, now I'm convinced it really was that chip and not, because there is a school of thought where you look at a symptom and then you try and ponder what it means, right? And you get into denialism and stuff, when you could be going around the scope looking at all the other signals too and find out what else is broken.
Well,
That was, go ahead.
When I said it's not always good to just swap chips, occasionally though, that's the faster way to fix something. If it's all socketed, so you're not going to ruin it worse by taking a chip out. Oh, I'm like, well, I think it's the MT RAM, like you said, the Micron RAM is just basically the 64K stuff is all garbage at this point. So it's got MT RAM. I'm going to feel which one's hot and then pop those chips out, put new ones in, and now suddenly it's working.
Right.
Like it's
so what we did in the hardware lab, you know, I did the 128 back in 85, 84 going into 85, and we had 5 months to do it. So I certainly could fix anything that break, but I didn't dick around either. And so if I worked over 10 minutes on a system that's dead, I had a full set of socketed parts. I'd swap them in, and you know where the other set would go? In the trash. Because I work for a big company whose time, you know, our values on time, as opposed to the few dollars of a chip. And the loss of time of putting a bad chip back into my rotation wasn't worth it. Absolutely. And so after 10 minutes, I'd swap them out, and I'd expect it to still be dead, you know. But if it suddenly came to life, I'd be, oh, good thing I didn't spend any time, you know, on the, but this is when you have analyzers and all this, but why use an analyzer to prove something, you know, if you can save 10 minutes, you know, but that was on the workbench. That's not, or on the design bench. That's not on repairing old retro stuff.
Yeah, even if you were doing that repair work back then, like, you know, there were repairmen for the 64. They had every chip available to them, easily attainable. So absolutely, if you took 5 chips out, all of a sudden it's working. Well, I'm just going to throw these away because I don't want. Yeah, like you risk using a bad chip again, and that could just cause more problems for another machine.
Right.
But yeah, nowadays we're like, oh, we don't have it. So, you know, if you've seen, my viewers on this stream won't see. I always use my dead parts bin, which I will grab, which I do keep them but I make sure that I always draw an X on them.
X, right.
So that I know it's bad. And this was sent in by a viewer. They made this case for me. Rami is one of my characters, but these are all bad. There's a lot of Sims and stuff in here right now.
Yeah, all my Sims got thrown away years ago. Yeah.
Well, I test these. Viewer sent in this incredible RAM tester, but there are like,
I saw that. Yeah.
Here's a 6560. That's a VIC from the VIC 20, for instance, and it's got an X on it. I draw an X, but I do keep these, and I don't know why I keep them, because everyone's like, not everyone. Some people are like, why don't you just throw that stuff away? There's something cool about I can see how much I've repaired, and this, believe me, this is only, I have another box that's bigger and even more full. It's fun to see how much I have found that's gone bad. That's cool, but sometimes I'm like, let me see what marginal SID chips behave like. And I have a whole bunch of marginal SID chips in here, and it's fun to pull those out and put them in real machines and just listen to the crazy sounds they make and all the other things that go wrong.
Right.
I don't know, I'm kind of weird that way.
We've done similar too, where maybe we'll put a color dot on it. It's like one strike. Maybe it's not dead. I'm again talking the R&D lab, but it's like, we don't trust you type of thing. So, hey, somebody asked early on, in the realm of 8-bit machines, what do you think of the old 8-bit machines, the Apples versus the Commodores versus Ataris? What's your take? I'm known for being biased, so I'll let you go first. But
well, my history when it comes to 8-bit machines goes back to the VIC 20 originally, like I mentioned. Then I was a huge Apple II fan. And that was just because that's what we got as a family. So you kind of fall into the camp of like what you have access to. But I had friends, that had other machines like a TI 99, Commodore 64, stuff like that. But I was a huge Apple II fanboy at the time, like big time. But the funny thing is now that I've had access to all this other stuff, like I've never even played with an Atari 8-bit until recently on the channel. I did some videos on it, and there's a 400 sitting there. My perspective has shifted. And for me personally, my feeling is, of all 8-bit machines, the best computer of all time is the Commodore 64. And please keep in mind, people are going to be saying that
home computer. I call them home computers, but yeah.
Yeah, okay, good point. Because like there's the K Pro there. That's an 8-bit computer too, Z80, but it's not really. It's more like a business machine, but something that a kid would use because there's fun games and color graphics and stuff, which the Apple II falls into that category, right? It's got color, monochrome that works color. Anyways, my point is that having used all these machines, and I know this is like super controversial, for me personally, the Commodore 64 is just incredible. Like for what the designers were
games, it was a multimedia experience for the 1982.
Yeah, and like it was the Atari 800 in '79. Sure, that was really great and
had all those colors. Yeah,
that had, and even has stuff that's better than the 64.
But it does.
But there's something about the 64 that maybe it's just the fact that there's so many of them, so there's so much development for it. And because obviously a computer that's great but has no software is not a great computer. Like it's technically great, but you need the software to be there too. And that's what the 64 has going for it over everything else. Apple II has a shit ton of sorry.
That's fine. That's
crap ton of software. But it's got I had an Apple IIc when it came out. My dad got that for me because he could tell I was big into technology and I would be going somewhere with my life in technology. So he made this amazing decision and got me this Apple IIc. But in 1984,
that's a lot of money.
Well, it was expensive, and like compared to a 64, I wanted to play games. That's what I did a lot of. The 64 was just a billion times better. So, anyways, it is what it is.
Right. And so what Commodore did real poorly was address the educational market. We had one educational person in our company that was in charge of that channel, only one. And so Apple cleaned up. If you went to school, you saw an Apple.
That's right. And in North America, which is where that's the case. I know in Europe that was not the case. But the funny story is, Bill, when I was a kid in like third grade, this was in Canada, or maybe second grade, we had Apple II pluses or Apple IIs at our school. I remember this is back in Montreal where I grew up, and I was in the computer lab playing with those. But I moved briefly to Vancouver, British Columbia, so West Coast, and that classroom had all Commodore 64s with 1702 monitors, beautiful color screens, and some Commodore pets. And that was the first time in my life I'd ever seen a pet. And I was like, weird because it's the same basic. Because I was a VIC-20 user owner at that time, so I knew how to program Commodore Basic, and I was like, it's the same, but no color, but 40 columns, but ever since that third grade experience, I was like, these Commodore 64s are awesome, A, but then B, this PET is amazing. And that's
Right.
like what has got me always to want a PET, which now I have like multiple of them.
Multiple pets. Yeah.
Yeah. So anyways, so in some places, education seemed to go the Commodore route. But once I moved back to the East Coast, it was back to Apples. And then, through the rest of my high school, junior high, it was all Apples. So that's what Apple was really good at. And I think that cemented the place of the inferior, sorry, Apple II fans, but the technology of the Apple II, except for the 2GS, really was inferior compared to the other machines because it's 1977 technology.
Right.
It is what it is.
They were first. It took me a while. I had a lot of denialism about Apple versus Commodore till I backed up prior to 1980. And then the more I looked at it, the more I'm like, oh, they were clearly first to do this. The floppy drive. I didn't realize that. And Commodore suffered from the fact that our cassette drive worked. Had it not worked, we'd have jumped right to floppy drives. But because the Chuck Peddle, the father of the 6502 and the PET series, he did the code on the cassette. And he made it so that you could literally stick your finger on the capstan of the recorder, wobble it, slow it down, and it would still work.
Amazing.
So he was dedicated. He said no. And him and Jack Trammell, I'm told, would fight about this. And the end result was we didn't have a fast flop. We never had a fast floppy, and we didn't have a floppy for a long time. So had you heard the story about why the Commodore floppy is so slow?
Well, I had heard that like it obviously wasn't slow on the PET because it was IEEE based.
It was 488. Yeah.
But then, and it, very similar to the operating system, right? But then later, VIC-20 was a bit slower. But then all that bug in the bad line or whatever on the 64.
You got it. So what the problem was is on the 6526, there's a hardware shift register. So they were going to use a hardware shift register. It would literally run as fast as the silicon of the day permitted on a party line, right? So it was going to be cool. Except we make our own chips, and part of making your own chips is you make your own bugs. We know this. We know how to determine them and debug them and stuff. And the bug was when you went from listening to being an output, a charge would accumulate internally, and it would couple that charge to the bus and put a glitch out on the bus. Well, it's a party line. Everybody'd go, what? Oh, huh? What? And lock up, right? So they ran it to the I/O pins on it and they bit banged it, right, for the VIC-20. And a guy named Bob Russell hedged his bet and he put in 2 traces going back to the hardware shift register. So it's like, all we need to do is change the code and the hardware shift register will start working and we'll forget about the first 10,000 units. Commodore Japan saw that it went to 2 places, thought it was a mistake, and they literally inked it out we used photographic film back then. And so they ruined our chance to fix our serial bus. And this is like 1980, 1981.
Was that going to be was that for the VIC-20 or for that Max?
That was the VIC-20. So then it got even slower and that was the 1540 drive. When we got to the VIC-2 chip, he would go, everybody, stop what you're doing. I need to go fetch some sprite pointer fetches, right? And everything stops as he does the DMA. And the DMA was radical. I mean, when Albert Charpentier thought to do that, it was like, wow, the way we're sharing the bus. But the problem is now your bit banging has to allow for a 40 microsecond jitter. So we went from needing 20 to needing 60 microseconds per bit to bit bang it through. And other people found ways, I used to carry a Mach 5 cartridge around, which was a speeder upper. I can tell you 2 things. One, it would put a 128 in a 64 mode, which I was always doing.
Yeah,
there you go.
An Epix.
Yep. And it would knock it into 64 mode. Second, my programs would load way faster. So other people did it better than us. Let's put it that way.
Well, it's amazing, isn't it? That like those, and then, the cartridge-based solution, but then the Jiffy DOS and stuff like that replaced the ROM in the disk drive. It's so freaking fast and over that same bus. Aw.
Yeah. You. Great. Yeah. Let's find another one here.
I know. Sorry, there's lots of questions. It's flying by.
Oh, somebody's watching you. Oh, so that freaked me out when you pulled. I did not know it was a Mitsumi keyboard on the Atari 800. You flipped it over, and I went Mitsumi. I mean, you know, I was so hardwired to knowing that manufacturer.
But
I've been to the Mitsumi plant in Japan.
Mitsumi keyboards on the 64 though are pretty damn reliable things, and they don't use that stupid membrane that the Atari 800 used. And I think Atari at least had 3 sources for their keyboards that were completely different. They not even similar at all. So you never knew what you're going to get with them. And apparently that's the most unreliable one that I got, I think, at least.
Right. And prior to working at Commodore, I designed instrumentation, and we helped the industry move forward on membrane keyboards in industrial environments. And I worked with a manufacturer called Brady, and we made one that could handle steam washdown and stuff. So I went to Commodore knowing how to design instrumentation. I know how to make stuff expensive, overpriced, very accurate, and highly reliable. And I got to Commodore, and I'm like, oh, this is different. And the moment that changed my life was I opened the C116. Do you have a 116?
I do, actually. Yeah, in a box, original box and everything.
So I opened a 116. This is from Rob Clark, by the way. You've mentioned him on your show. He sent me one because I didn't even have a 116. Nice. And I wanted to show my son what I used to do. And the 116 to me, even though nobody'd use this. Let's be real, but it's cool. It's a work of art, right?
So small and pretty. Yeah, absolutely.
Yeah. It's the Raspberry Pi of its day, except it's got a power supply and a case and a keyboard, right?
I agree.
But I looked in here, and they had this power resistor right here, right? There is I've never put a power resistor on a circuit board that's not a power supply, right? And I'm like, what are you putting a 5-watt? We call those sandbox resistors, because the way they look. And I'm looking, and what they did was they bypassed the voltage regulator. As long as there's at least 200 milliamps of load, that makes the 3-volt drop you need to keep the regulator in regulation. I would never have thought, oh, it'll always pull at least 200 mils. There are no specs for minimal current pull, because we always try and make it as small. But I'm like, they bet that, I was like, it was a moment for me. I was like, oh, we're making consumer goods. Okay, I got it. And my life changed when I saw that power resistor. I did. I became a Commodore engineer, looking for that shortcut times millions, right? Because we couldn't put a heat sink big enough in here. We look how big it is now. It takes up the rest of the room.
Yeah, exactly.
Yeah. So Commodore, if we saw a shortcut, we win. You and I talked about this. We were consumer goods, toys.
It's the funny thing is, Bill, that results in because if you have like money is no object, you don't end up with the most elegant solutions. And that's something about these Commodore products is like, they were obviously, Jack was pushing you to make the cheapest stuff. Right. And that really resulted in really smart, like cool decisions, at least with, some of the machines that just to this day, that when I look at it from an engineering perspective, and look, I have no skill at this, but I've repaired enough things to go, this is really smart and cool ideas that they did here. And look, Woz on the original Apple II, tons of amazing things were done.
There's cool stuff in there. Yeah,
absolutely. But later Apple got kind of like lazy in a way, and it just, the cool factor is just not there anymore. And Commodore had a bunch of products with like amazing cool stuff. I mean, even the Amiga, which I know wasn't designed, in-house originally, just freaking amazing stuff going on in there. And that's what I love. Now, Bill, I have a question for you.
Okay.
Someone asked me this, so I saw it go by in the chat. They're like, what's your favorite MOS and what's your least favorite MOS chip? Now, I have to say, having worked on pretty much every Commodore at this point, the most unreliable machines are the TED machines.
TEDs, right.
So why specifically is the CPU the most failure-prone device on that thing?
The very first part, so the 6500 parts are NMOS, regular NMOS design rules. I think it's 1.7 micron channel length, something like that. Then we did a shrink called an HMOS1 shrink, and that's where the 7501 came from. So we shrunk all the features on the die. But it's like anything, you shrink all your sidewalks and stuff and suddenly find out there's a gutter missing or something. You know, mechanically, it's not linear, right? And then we did another shrink. It's 10% each time, 10 to 20, 10%. The 85, whatever, 01.
01, I think, yeah.
Was even another shrink. So not only was it a brand new process for us, but making chips back then was like baking as opposed to chemistry. It was a recipe with art mixed in. Making chips was an art form. Getting your yields above 30% was an art form. So the TED chip was our very first one of that line. And I'm surprised any of them work. We design stuff to last 3 to 5 years. And that pisses people off when I say that, because they're like, my 35-year-old TED broke its TED chip. Well, you got 30 more years out of it than I expected you to get.
I think, like when I find hard drives, like old Seagate drives that are from, the early 80s too, and those work, I'm shocked, because when I read the data sheet for them, they're always like design lifetime 5 years. And I'm like, it's still working after 30 and it's mechanical. Like, what the hell? How's that even happen?
Right. So we really are, you know what it is. And the reason why they're still working Commodores is because there were so many Commodores to start with. They're, depending on what you believe, there's between 12 and 27 million were sold. It's at least 12. That's my opinion. Go ahead.
Well, I mean, it certainly seems that like the fab got their chemistry baking going good, because
it got better.
The 64C, the 128. Generally, everything on those always just seems to work.
We got it back to equilibrium. We still broke stuff. I mean, it's still toy stuff, right? We still squeaked by on our. We didn't throw away chips if they were marginal. We shipped the chips if they were marginal, to be totally honest. And I could tell you stories, but we had stuff. We called it the Christmas rush. We would ship bad known computers to get them under the Christmas tree. And if you brought it back in January, our attitude was still got under the tree, didn't we?
Oh, wow. I mean, it's funny that you mentioned that, because having worked on so many of these machines, sometimes I notice there's like random socketed stuff on them. And I'm like,
whoops, I'm sorry. I'm just going quick on that.
Oh, that's okay. I was like, what? Oh yeah, Mr. Oh yeah, okay. They're working on Mr. I love the Mr. Everyone. I'm a big fan of that particular project.
I just loaded Mr. myself about 2 weeks ago.
Oh, that's awesome. Yeah, I didn't. There's a C128 core coming. That's awesome.
Oh yeah. Somebody said yeah. Shout out to Tim and Brian, who told me to check out your site originally, and they were loading Misters, and then it's funny to see current technology people doing FPGA emulations of 40-year-old stuff. That's just cool.
It's funny because like some purists, I don't know, whatever, like say that using FPGAs to emulate stuff like say a SID chip is ridiculous, because the SID, an FPGA could just emulate the entire machine. But I am personally a big fan of this movement of using FPGAs to get working machines again, because as these chips die, I mean, and Bill, you were just saying, I mean, eventually the design lifetime is far exceeded, and we may end up,
with like shouldn't be any working,
right? And so the only way to run this stuff is to potentially emulate the chips that are dying, or maybe eventually, well, they already have it, like the entire machine, of course, and then you could use the case, so you can get that like feel, that look and feel of the old machine without having it. And I love that the 128 Maxi, it's that brand new reproduction 64. I think that's a great thing, because it allows people to get back into say the 64 without having to buy this unreliable old piece of hardware that's potentially really hard to keep running.
Right. Oh, I pissed off a lot of people. They'd say, "What do you think of it?" I'd say, "I'd emulate it."
Yeah, I mean,
no, I've gotten better the last 2 years about going, "Oh, okay, I get the retro thing." Yeah.
Oh, yeah. I mean, and look, I'm a proponent of obviously original hardware, and for me, CRTs are something that you can't replicate with emulation. It looks bad, compared to looking at a real series. Something about it, for me at least. But I also see that I personally can keep this crap. I don't want to call it crap because people are probably offended by that.
It's crap.
It is old junk, right?
No.
I could keep it running.
You might be in love with it, but it's still old junk.
Yeah, I mean, it's the old stuff that's constantly breaking, and if for me, that's a challenge and fun. But for most people, they just want to play the games they played when they were kids.
Right, right.
And in that case, the emulation works really, really well. Nothing beats the current, Crunch of a Real 1541. See, now, as I had talked about, when I was a kid, I had a VIC-20 and I only had the data set. So I never had a Commodore disk drive. And then I went to Apple II. So, and I was used to like the WAS Disk 2 interface, which is fast and really ingenious the way that's made. But I never heard the head banging 1541, put your cold hands on top of the disk drive to like warm them up in the winter, you know.
Oh, we used to keep our coffee stirred. We'd keep the sediment stirred. You know, it is like the scene from Jurassic Park, you know, with the waves and stuff on your coffee.
You know, it's funny. I have a video, Bill, you may not have seen, where I took an old 1541 and I put a switching power supply in it. So I took out the giant transformer. And when you pick up the drive, you're like, whoa, this thing doesn't even weigh anything.
The guy that designed the 1571, I mean, we were working long hours, like, you know, 18, 20-hour days and stuff. And one of the things he would do was he would put his head on the disk drive to listen if the steppers are still going, if it crashed, and he'd fall asleep. So you'd walk in, there'd be the 6'8" guy with his head flat on a drive, snoring away, and you'd actually be quiet around it, you know, so that he'd get his sleep. So it's yeah.
I love it.
Hey, so one of your first shows I saw was on the jail bars of the 128, and I looked at that. I went, oh my God, look at those jail bars. I don't remember those. I mean, I remember them. I don't think we ever even used the word bad. I'm a critic, right? Like when the C128D metal chassis came out, and that wasn't done by Commodore Westchester, and it was done years after I was gone. The first thing I did is it's noisy. I could see ground loop noise in it and all kinds. But underneath there, I realized that I had some denial. When the VIC chip made those bars that we see today on HDMI things, I go, look how bad those are. Why didn't we fix that? But back then on a CRT where contrasts were different and our expectations were different, it's like I knew they were there, but it was the best the VIC chip could do, so I didn't worry about it. Now in hindsight, I think I'd go back to the chip guys and go, can we add 4 more ground pins to the chip? You know, how do we fix this ground noise? But back then it was just accepted that that's the noise coming out of the VIC chip.
I mean, it's weird too, because on the bread bin 64s, there are like the one I use here. Oh, and I don't know if people have actually seen this. I haven't shown it. So this is my ZIF 64 I used for testing. Now it's in a Bitcoin case now. Yeah. It's as we can see, it's no longer the bread bin color. But in this machine, which is the same old motherboard everyone has seen, I have a big MSI heatsink over the VIC-2 there.
Right.
The weird thing is about the jail bars on this machine is they're bad sometimes, but other times they're not. And the differentiation is turning it off and on. If I power cycle it, every other power cycle has bad jail bars, and then the other one.
I did not know that. So it's hitting a phase of the master clock.
Yeah, and this one has one of the ceramic like R8 VIC-2 chips, like which
came out right when I got there. Yeah, the R7s, R8s. Yeah,
but
R7s.
The C128s, on the other hand, and I heard, and I don't know, you maybe could confirm or deny this, that of course you're using the VIC-2 on the 128 for much more than on this, right? It's a 48-pin package. It's doing some extra stuff, and that's why the jail bars are worse on the 128. Do you think that's even likely or possible?
So back then, the 128 had a cleaner display than the 64 because the 64 flickered.
Huh.
So the 64s flickered so badly that we did a couple things. One, we went in and we made it so instead of the unused cells on the blue screen, you know how they're light blue on dark blue for well, on every cell that doesn't have a character in it, they changed the foreground color to dark blue. So now it's still flickering, but it's flickering dark blue on dark blue.
And you can tell if you take the character ROM out, you can tell that's happening because only where there's letters do you see the flickery from the lack of character.
Okay.
The floating line.
And that's exactly why. So we actually were better than the 64 by such a margin when I was there that we didn't see the 128 as being noisy. And of course, now I do. Now I look at it and go, oh my God, the 1980s had such bad, jail bar noise,
It's weird that I don't even know why I care about it, because like you said, back in the day, people were using like TVs and composite, and it all looked terrible because of like the way.
Oh, picture channel 3 on your TV. Yeah.
Like it was all noisy just from the way it was connected. So the fact that I seem to care more about it, and like right here on my desk, that's stuck on a. So here's like a 64 RF modulator, and I have it here because I do these mods to this by cutting some of the capacitors that filter some of the signal in the inductors and stuff, which cause a smearing, really improve the video quality on the 64. But you're talking about like that sparkly stuff, I think, which is coming from the VIC itself, right?
It's from the VIC itself, right?
Not in the analog part. But once these mods are done to like that old 64 down there, to me, it looks just as good, or if not better, than a 128 because of the every other lack of jail bars.
Right. So, the thing we did, we used the modulator, it's Mitsumi modulator, to make our composite for us. So we sent them the signals. Well, as you pointed out, there's smear. There is a delay between chroma and luma.
Exactly.
Right? So what we did in the 1702 and 1701 was we engineered it to take the smear back out. So it was worse on other people's monitors than our own. So, but that's the thing about owning the entire supply chain, right? We made the chips, we OEM'd the monitors, and to customize something like that was just a normal day at Commodore.
That's funny. I never even considered that, Bill, because I don't use I have like a couple 1702s, but I don't use them much because they're so low resolution. The CRT dot pitch, which is why I stick to the 1084s if I'm going to use a CRT.
Right.
But yeah, like, so I have the modification. There's a video, if anyone's interested, you look through my channel, where I modify the 64 RF modulators to take that smearing out, which remarkably improves the picture quality on that, but also on HDMI or whatever you have it hooked up to.
Right.
And you don't need to do that on the 128 or the later 64Cs. That's not a problem with those. But yeah, the jail bar stuff. And so they're those what do they call it? Luma Fix or whatever they call the little board. Personally, I mean, everyone, again, controversial here, I have never found those to do anything that are any good. Like I have them for the 64 and the 128, and neither, I mean, it tries to counteract it, Bill, by, a negative.
It differentiates the signal and feeds it back into it.
Yeah. Tweaking all these pots, and it's like, it might be better sometimes, but other colors look worse. So I just don't even bother.
You're basically using another source of
noise,
structured noise. Exactly. And you're summing it in, hoping to get less noise in the process. And okay.
It's sort of like what do you have here? Is this some kind of
that wire? You've seen that wire.
I've seen that wire, and I'm like, it's on every single one of those machines.
There's 7 million of those wires. They probably cost $1 each, a penny for the wire, and probably 99 cents to install it.
There's all that.
You ever hear the story?
What's the story?
Even hot glue. Have you ever heard why that wire is on there?
Mm-mm.
So we go to CES show 85. We call it 84, but then became January 85. And then we had time to rev the PC board one last time, but we can't move any chips. We've already applied for FCC in December. They've already got it in the lab. We're allowed to make little cuts and jumpers and stuff, but we can move traces, but we can't move anything big. So we do this board in the 2 to 3 weeks in January. Go out to FCC. Everything works. We're going to release in March, April, May. We'll be in heavy production, and we find out that CPM doesn't boot 20% of the time on the Rev 7 boards, and there wasn't even supposed to be a Z80 in the 128. Whole different story. We put one in to fix something else, and now it has to work. And so, what do I do, right? So the full story is me and my boss got in a fight. He's like, fine, I'll take you off the project. I'm like, fine, I'm going to go take a shower. I'm going to go take a nap, And I did. For a week, I just relaxed, I chilled out. I kept my powder dry. At the end of the week, he comes to me and he says, fix it or you're fired. Because the other engineer, he got nowhere trying to figure out why 20% of the time Z80 wouldn't boot, on this horribly complex computer. And I got lucky. I found it within an hour by staring at an oscilloscope where I had taken the trace off the bottom. So only the little glitches. and I knew it had to be only during Z80 time. So I'm triggering on Z80 time, and I'm looking, and I see this ghost of a glitch. So what I did is I stared at it, and then I would look up at the white wall, and I would see everything in reverse, and I could see a glitch. And I called another guy over, Frank Palea, who did the Z80 stuff, and I said, stare at it. Now look at the wall. He goes, I see it. I see the glitch. And there was, we just about 3 months ago, we stuck it on my bench using high-speed equipment, and we could see crosstalk when we cut that wire. And so what I did 38 years ago as a young kid who was like, oh, there's the glitch. I'll just make it so that I'll give it another path to between the Z80 and where it's going. And that fixed the glitch. But that's why that's on every one of those. We didn't want to spin the board again, because if we move that trace, it might have glitched someplace I couldn't fix.
Oh, because so even later, like after a couple years of production, there was no impetus.
No impetus to move it for a wire. It only cost. It really didn't cost $1, but I say it cost $1.
Well, I was gonna say, so you cost Commodore $7 million with your hacking.
Right,
trick.
but I'm in the $1 billion club. The 128 probably made at least $1.5 billion. You know, so it's yeah.
So
well, do you know what? They paid me $24,500 that year to do the 128. That was my salary back in the 80s.
Was that competitive or like not at the time? I don't
It
even
was
know.
really good for a high school dropout. It was really good. So I had no complaints. Some of the guys that worked for me made more than me, and I didn't care because they had gone to school. They put the time in, right?
I've been in that same spot, Bill, where
Yeah.
I've had people working for me that made more money than me, and I was just like, this is weird, but whatever. Yeah, what can
Right. You work it out. Yeah. So, hey, you asked about on one of your shows, you had a TED, which what we call all of the +4s, 264s,
264s,
364s. Yeah. And you're going, what's going on this power connector? It's square.
Yeah, what's the deal with that?
The original 264s used a Commodore 64 power supply. We went almost a year using Commodore 64 power supplies. Then Jack Trammell leaves, right? But there's still a Trammell working in Commodore Tokyo where the problems arose. And they changed it to a square plug on the PC board layout. I changed it back. I found it. We changed it back. We even did something to make it compatible with both. I think you may have even noticed there's a hole there. And we said, aha, we win. We made the last change. And they did something else. And then we found that they changed the plastic to be a flammable plastic that's not UL listed. But we found it. We changed it back to an anti-flame plastic. So there's this going on in the background, right? And then finally they got me. When we got the new cases in, they'd made the whole square on the case.
But why was this big? Would they want to sell a different power supply or it's higher amperage or what?
There's no good answer for the why, other than it came out of Commodore Tokyo under the old Jack Trammell reign after Jack Trammell was gone.
Because like I get it with the 128, there was a square connector too, but it was a higher amperage machine, right?
It's a higher amperage. It's square, kind of squared up with the we didn't mind it there. Yeah.
But like there is a mod video I did. My very first 128 I ever got. I got it alone with no power supply, and I wasn't gonna go spend the ridiculous money for a power supply. So I swapped the connector for the 64 round in, and I don't use the original bricks because the original 64 bricks
they're dangerous now.
They're dangerous. Yeah. So I built my own, and it's a 4 amp, 5 volts or whatever. So I run that on my 128 and 64s, simultaneously. So, but it's the TED machines, and I was like, clearly, like you look at the specs on the power supply, it's exactly
identical. Identical. So your comment about why didn't they? Well, we did till we didn't.
You tried your hardest.
I tried really hard, but they got me when those cases arrived that had square things on them. We lost the war. We had another war going on because the joystick command. Remember, we put BASIC in there where you could read the joystick from BASIC, right? And to read it is joy parentheses 0 paren, right? To read joystick 0. So we made the plastic on the case say joy 0, joy 1. We started counting from 0. Marketing people hate that. So they got hold of the plastic and they made it joy 1 and joy 2. And Terry Ryan, the guy that wrote BASIC, I just remember him going, I'm not changing it. I'm not changing BASIC to match the case.
Well, I know on like 128 BASIC, there's a couple instances where, yeah, it starts at one. I watched Robin, 8-Bit Show and Tell's channel, and he talks about all the weird BASIC stuff. Yeah, and there's like some commands where it's 1, 2, 3. There's no 0, but other commands it starts at 0, and I was just like, it's a little inconsistent. But it sounds like on the TED machines, it could have been Joy 1 and 2 and BASIC 2, but that would have been weird. But maybe, I don't know. That's so funny.
Right. Do you think about programmatically or as a user?
Right.
Yeah.
And you think, go ahead.
Well, I was going to say the guy that wrote that BASIC, Terry Ryan, and he's the guy that made the link arms don't make them. Right. That's Terry. If you knew Terry, we would always get messages whenever we're debugging. You knew something was working if it said, "Don't take any wooden nickels." He'd give you advice through his code, right? So, but he got in trouble. It was his idea on the 128 to add all the structure, do, loop, while, until, for, all that junk, and he got in trouble for it because his boss had said, "Well, I told you not to do that. It appears that you did the right thing, but I told you not to do it. So no raise for you." And that manager eventually got let go, but Terry got like a 2% raise for writing BASIC used by millions of people,
and adding extra functionality to like really make it better as it is on the 128. Interesting.
Yeah. Oh, Terry's a funny guy too, because he claims to not remember that era at all. So I have to tell him, "Yeah, Terry, you wrote BASIC for millions of people." He's like, "I did."
Maybe he's like blocking out the stress of it all or something.
Yeah, right. Yeah, exactly. The 80s. It's like, I have proof. I mean, there's an Easter egg with your name in it. So that's.
I think that's. See, I mean, like, and again, I was using this stuff back in the day, but not designing any of it. So it's so cool to think that your handprints are all over these machines, and all your colleagues that work with you. It's just. And I just something very immutable about that. And I guess the fact is we make videos now, and maybe those will be around at some point in the future. Will anyone be watching them? I don't know, but tangible devices that you engineered, that's just super cool to me. I love the fact that, I love the fact that hardware design is democratized now, with these companies in China where you can make PCBs for $5 and that kind of, like, how crazy is that?
Yeah, just I spun a board in 5. It was here in 7 days, including shipping from China. Yeah,
I mean, it's like I use KiCad, however you say it, and spun a few things on myself, and I don't even have any education of anything at all, and I made working stuff, which is like crazy to me.
And in the old days, it was hand tape, right? Who could do that? Because who could make the board? Well, as a kid, I should say that was our holy grail, was making your own PC boards, but they always sucked.
When all those chemicals you had to use and stuff.
Yeah, ferric chloride. But you could go down to Radio Shack and buy the chemicals.
I remember. Yeah, you could buy the copper. You had the copper PCBs, right? Then you do the photographic thing and the etching or whatever.
And you learn to clean them after you screw up the first one. Then you're like, okay, cleanliness counts. Then you screw up the second one. You realize you can't have them upside down or it scrapes off the stuff while you're agitating it. And you learn that you have to agitate it if you want it to work. And
amazing. Do I feel like I missed out on that a little bit? Maybe, because when I read those old Byte magazines and stuff from the old days where they have like PCBs you can make at home, and I'm like, how cool of an era is that? And that's I'm kind of getting into that now with my Southwest Technical PC 6800, from 1975, when people you had to make your own stuff because there just was no industry yet, right? It was just the beginning of the era.
Right.
So super cool. Yeah. What was your first computer? I'm curious.
My first computer, hang on. It's the company that I did instrumentation for started on one of these.
Right? One?
Yes. Oh, they had the 16K RAM expansion and everything. But when I started 2 years later, not started, but a couple years later, we had a Rockwell System 65. And we did that to program our 6502s and our digital weighing instrumentation. So my first computer was a work computer for work. my first home computer was, I got to Commodore and they go, here, take one home. I went, this is great. I was saving my money for an Atari 400 because I couldn't afford an 800. I had even bought a tube of 64K DRAMs for like $100. I was going to make my own DRAM expansion for a different thing I was working on. And yeah.
Wait, so it was a 64 they gave you, or a VIC-20 as your first?
It was a 64. Yeah.
Do you still have the machine?
Oh, no.
Long gone. But, yeah, me too. All that stuff's long gone.
So I had taken, this is a Motorola board for a 6801. And I had bought it and populated it. And then you can see the healthy changes. And so I can't believe I still have this. This was in a box. I have nothing else from the era except this, where I adapted a 6800 board to a 6502 board. And then I did bus sharing, where just like the VIC does, where fee 1, fee 2, fee 1.
Yep.
So I was literally doing that at home using pre-made, semi-pre-made, and then I'd plug my Rockwell System 65 to write code and stuff. So my first computer was this. I never even thought about it till you asked it that way.
That's so cool.
Yeah. So that's how I ended up in charge of TED. When I got to Commodore, they hired me as a technician. They just I'm told they wanted me, they knew I had something going on. So they hired me as a technician. They sat me down in a guy named Benny Pruden's chair and said, you're writing code for disk drives for Benny. I said, fine, I just like working here, right? He was gone the first week, so I would read the code for half an hour, and then I'd walk. And then I'd read the code some more and I kept walking to the hardware lab and the chip lab and all these. As a kid in a candy store, it's like, right? And I got so enthralled, I forgot my story. Oh, so I'm there and they're showing, oh, this is the TED, our newest computer and stuff. And I'm like, oh, are you doing the bus sharing thing where you're jumping on the button? They're like, yeah, how'd you know? So I'm doing this at home, Well, it turns out the guy was leaving in less than 2 weeks. And he walked in and said, I think Bill Hurd should be in on this new project. So by the end of like the first to second week, I was in charge of TED and I was a new hire. And it was all because of that board I just showed you. I know it was my enthusiasm for that got me into that slot. And they said, you could be a hardware engineer.
And it was all like that board, with your modifications, it was all just like kind of hardware hacking, which translated into your fix on the 128 motherboard,
Yeah.
Oh, yeah. Out of bodge wire. Did you guys call it bodge wires back then?
No. I didn't even say the word bodge till I actually went to do the PC board, say it out loud. It was just the wire. It was just I thought it was a reflection, right? I thought because we had a 6502 and the multiplexers, and I engineered the heck out of that, right? But here's this other processor, the Z80, and he has to jump on the same bus. Well, he can't be a terminator. The 6502 is the terminator. The multiplexers are the other terminator. So he has to, it's kind of like blowing a flute in the middle, right? You can't blow on either end. Well, I thought it was a reflection. So the real reason I added that wire was so that when it get to the end, it wouldn't reflect, it'd go around. And it was only later I figured out that it was like it's a crosstalk. And so what I was doing is I was reducing the impedance by actually having two coaxes, is the way to think of it. If a trace is a coax, I added a second coax. It said, here's no crosstalk for you. And I even routed it over the ground. That's why it does that zigzag and stuff that it does.
And did you have digital storage oscilloscopes of any kind back then?
No. Well, we had a Tektronix 466, which was 100 megahertz bandwidth, and it couldn't capture a single. We could use it to reset the reset pulse, troubleshoot the reset pulse. That was it. And then it'd be all weak. And the background, no contrast.
It had that phosphor, persistent phosphor thing.
That's exactly it. So you punch the button and it would flash and clear.
Yeah,
and then you would
I just saw a video recently on that. And I was like, I'd never even heard of that. But yeah, somehow it keeps a faint image, right?
There's a storage grid. Yeah. Yes. So as it writes to the grid, it imparts a charge inside the CRT. And then it stays there till they reverse the charge on it and dumps the charge off the focus, or off the grid. Storage.
So did you have to like turn the lights off in the lab to see the screen or whatever?
Yeah. You did. We had full Polaroid cameras. Remember Polaroids?
Yeah. I mean, it's amazing. I'm still amazed. Looking here in my drawer. I have this little portable, Chinese scope here.
Right.
50 megahertz, whatever. There's 2 channels, and this thing costs I don't know, it was $120. And I actually use this all the time. People probably, I made a review of this, and I love this because like a multimeter, you can sit it on your desk when you're looking at the motherboard that's right here, and you only have to move your eyes like barely anything to see the screen. And it's so cheap and it's so functional. I mean, it has not a great user interface, whatever. That's besides the point. This stuff is so accessible now compared to when you were doing this.
Well, a scope cost twice my year's salary.
Yeah, like, so you would never ever.
I'd never be around a scope unless it was. And then to buy a 465B like I used to have off eBay for $120, you know.
I'm sure, like, that was probably, I have my very first scope that I bought. It's a B&K 20 megahertz 2-channel.
I remember those. Yeah,
analog. I got it from
B&K stuff. The real limit. Yeah,
but it works. I mean, it's funny. It's to this day, it still works. I never use it because the only thing it does better than all my digital stuff is the XY mode. You know, because the new
my digital won't do XY mode. Yeah,
like,
because I now have the Tektronix MDO 3000, M3040, whatever it is. So, and you can tell I've been doing real troubleshooting on the bench behind me. You can see that my scope. Normally, my scope sits off. Over there,
that one,
on a bench, but right now it's sitting on the bench itself, and that's because I've been troubleshooting. It's like you say, you want to just look up as you move your probe, and you don't want to be shorting out or doing anything, you know, by moving your head very far.
Yeah, because if you're holding on a pin and you move your head like this, you move your arm, and it like shorts the pin next to it. Exactly, it totally happens.
Yeah, and you got that ground collar behind the
But it's I try to show on my channel, like on my show, that this stuff is so cheap now that anyone, you know, these tools are so invaluable for troubleshooting compared to just like swapping chips or, you know, guessing or even logic probes. So really, if to anyone watching, if you're one of my viewers and you've seen me repair
I was going to ask, what do you recommend?
Honestly, like, get a cheap oscilloscope. And unfortunately, the used ones, like you were saying, like you used to be able to buy them.
You'll spend more on good probes than the scope sometimes, and then the scope's fuzzy, and you know, so it's buyer beware. But the probes are often overlooked.
It's amazing though that even like these cheap crappy scopes, like I bought a $60 2-channel thing, you know, a USB one, and
that'll troubleshoot a C64
exactly for like a 1 or 2 megahertz machine. It's plenty good, and the probes that it come with are fine for that.
They're almost just coaxes with the tip.
Yeah, it's 10x.
But they work.
Yeah, totally. And like for troubleshooting, I have gotten far more value out of learning how to use an oscilloscope, because again, I never went to school for this stuff. So learning how to use one, and by watching Dave Jones, EV Blog, and other channels like that talking about theory and some of the gotchas, especially on digital scopes with like aliasing and other things that can happen. Gotta
know your tool, right?
Yeah, and that has upped my game. A good multimeter and a good cheap oscilloscope, you really can go very far nowadays.
Right. Well, you mentioned that. Here is something I do have from my early career.
An old
I have 2 Fluke 77s that for some reason I just haven't lost them. This one's been lost for a year, and I just found it in the garage in a drawer where it should be. It's been lost for a year because I put it away.
Hopefully the batteries didn't leak or anything in it.
No, they didn't. I should look. I should look.
I was watching like a Big Clive video recently where he was talking about, you know, leaky batteries, and I was like, oh crap, you know, I got to go check everything. And I've switched over to the nickel metal hydrides. I hear they leak less than, of course they leak long term, but less than alkalines seem to always leak now. I call Duracell Duraleak because I swear, if I open something and it's got a leaky battery, I'm like, another Duracell. But
okay, I never realized the one brand was.
I don't know. There's no science to that. It's probably that I have more of them than anything else. So, but anyways, yeah, like leaky batteries destroy everything. So check your batteries, everyone, or don't leave them in stuff, or you know, whatever. Anyways.
Well, it's funny you mentioned that because, you know, on my bench is a Commodore LCD, and it's one of 3. Jeff Porter, who took over the project, has the other 2, and his were actual demo units. Mine's a prototype. There was never batteries in it. He still has the AA 40-year-old batteries in his, and they leaked. But he turned on the LCD and it popped open. It ran for a second and died on 40-year-old batteries. And people are mortified. And I'm like, I tell them, you have to understand, it worked 40 years ago. To an engineer, we make horrible retro collectors. I've been at a VCF where I threw one of my boards into a bin across the room, and everybody freaks. And I'm like, with my best Charlie Manson smile, I'm like, did that make you nervous? And you mentioned Rob Clark. I now channel Rob when I'm handling my stuff because he is a collector, right? And he knows the value of putting heat sinks on, for example. He wants his stuff to last longer. Well, I don't put heat sinks on stuff because it doesn't have a heat problem if you're designing it to last 3 to 5 years.
Well, that's right. That's
Right.
right.
But if it's my unit at home, yeah, I'm going to do everything I can to make it, not break to next time I turn it on, which is when it probably breaks.
I mean, I tell you, like I had said about the SIDS, like I've had plenty of things break, like stored away and not even being turned on. They just work and then they're not working. So I don't really know. I mean, you're more an engineer than me any day, and I'm not sure they do the heat sinks. Could that even help at all? Is that even possible that it makes a difference?
To me, it doesn't. It doesn't. Yeah. Boltzmann's constant, right? For every 10 degrees you lower it, you get a little additional life. But to me, it's not the temperature it works at, because even sitting here, room temperature is still temperature. This is still hundreds of degrees Kelvin. Right? Right. So a difference of 20, but the thermal shock of turning it on. So I was like, well, what if we made chip heaters? And I mentioned this to Rob, and he thought I was nuts, right? I'm like, no, seriously, listen to me. Instead of cooling the chips, what we do is pre-warm them
slowly.
Right. Bring them up to temperature, turn on the current, and then start cooling them back off then. But I was after trying to reduce the thermal shock. So who knows if it worked, but that was my way of approaching it.
I mean, there's one thing. If you add a heat sink onto a chip, and like a 64, for instance, it's a terrible, there's not any airflow in there hardly at all. So if you put heat sinks, it's still going to get incredibly hot.
All you do is heat the air inside. Right.
Yes. But it will take longer. So I suppose because there's some thermal mass we've attached on top of the chips, that potentially slows down the thermal change. So maybe, but the die inside, of course, is still heating up. I don't know. I mean,
right. And so here's the heat sink from a 128. The most. First off, this cost me less than $1, so why wouldn't I do it, right? I passed FCC. These holes are there's math behind the size of the holes.
Sure.
It says you'll pass FCC. But then there's like, well, if we're going to enclose it, we have to add fingers, to draw the heat to this. The biggest advantage this has is that this conducts the heat as close to the edge of the chassis as you can to get it out of the chassis to begin with. And then the C128D actually had a fan. It was one of our first computers with a fan. And I remember they had the fan blowing out onto the keyboard and would actually blow on your fingers. And it was noisy. I turned to the guy. I remember I said, "Urusai desu." It's noisy in Japanese. And I said, I insisted. I said, fan needs to blow the other way. And so I was channeling Steve Jobs. And they're like, "Yes, Bill, we'll make the fan blow the other way." And they did. That's how we went to production.
I mean, you mentioned like that, people are gassed when you throw your prototype board around and whatever. But the funny thing is, like, I also treat the stuff that I have like, it's my stuff, it's yours boards. You could do whatever you want with it.
Right.
When I open a 128, I honestly throw away the RF shield. Well, I recycled it because it's steel or whatever. So it goes in the recycle bin. But I don't keep that stuff because like, it's just a pain to work on the machine with it there. So bye-bye. And I'll throw some heat sinks on the hot chips, right? But yeah, like, and people are like, I can't believe you're not keeping it original. It's like, it's my stuff. I can do whatever I want with it. And like, look, you tell me, there's a little bit of heat sinking on that 128 RF shield, but does it literally do anything else besides cut down on emissions? Right.
And the answer is no. It fixes its own heat problem that it creates for the most part.
Because it's enclosing the motherboard, right?
Right. Now, with that said, the VIC chip is he needs some help. We always knew.
Yeah.
And what made the Rev 7 and Rev 8 revisions of the VIC chip what they were is inside they went to a beryllium metal frame to hold the die, because conduction is better than convection for getting heat out. And your biggest heat sink is the PC board itself. When something's soldered in, 60 to 70% of the heat goes out the heat sink. So when we think of heat sinks on a part soldered into a board, we're just adding a second heat sink to it. So
that makes a lot of sense. Yeah, and it's just like I know I actually have one computer, Bill. It's a Mac Color Classic. It's like a little compact Macintosh that's a color screen, and Apple used the RF shielding to actually connect some ground planes. And when I had it apart, and the battery
you don't want current flowing through that. It can be a reference, but not current.
Yeah, and like basically, I was like pulling my proverbial hair out because the sound wasn't working on this machine. And I'm like, I don't understand what is happening. The battery had blown up and it rotted away the RF. I had to throw it away anyways. But it literally, I finally figured out it was freaking connecting the couple of ground planes. So I just figured that out. Once I got to the bottom of that, I scraped some of the solder mask off the ground planes. And I just soldered giant wires across, and it fixed the problem. The machine doesn't have the RF shield and it now works. But I was like, what are they doing? I don't even know why. I mean, I'm no expert, but I'm like, this doesn't make sense to me. And from
that doesn't make sense to me either. Yeah. What may have happened is the hardware engineer, if this is a final assembly thing, the hardware engineer may have been focused on the hardware in front of him, but not been authoritative over the full mechanical design assembly package. And we had that advantage is I'd walk over and, I'd want it this way or I'm telling my boss type thing. But that'd be the only thing I can think of is the hardware engineer wasn't part of that discussion. Well, and the mechanical engineer said metal's metal.
It was the 90s. So, by then Apple was a big, huge company, and who knows what was going on.
They might have been compartmentalized or something. Yeah.
But it just seems like if I were designing a PCB, I would want it to run outside of whatever it was going to go into without needing jumper wires, like to hook up ground.
Right.
Like that's just nonsensical. So that was the one machine that threw me for a loop, but never else have I ever figured out had a computer where pulling RF shielding off ever made any difference to like the stability or the operation of the machine. And it encloses the heat and it's hard to work on all those other things. So bye-bye.
Right.
Even though I know it horrifies ham radio people hate it. I'm a ham as well. I'm licensed.
Are you? Okay.
I am. I mean, what good, old school nerd isn't, right?
Right.
I mean, nowadays, think of all the junk we buy from China, like these LED light bulbs and stuff. There's no.
Oh, we did a show on the fake markings, even on the power supplies.
Yeah, exactly.
Ben's like, no, this isn't Australian qualified. This is not German. Oh, somebody asked earlier if we intentionally got into the European markets, and I'll tell you that Commodore owned Commodore Germany, Commodore England, Commodore Japan, and then other place, Commodore Italy. And so, yes, we were very European market oriented because the only way you could sell into Germany was have a subsidiary in Germany. They wrote the VDE FCC laws that if you didn't speak German and weren't there, doing the exact right thing, you'd never pass and you wouldn't be allowed to sell into Germany.
Yeah, so it was a serious business at that point.
It was serious. Yeah. The matter of fact, the Commodore German lab, we were almost in competition with each other. We'd like vie for the top slot in production, things like that. But I'm sure they were as big as us, as Westchester was at the time.
It was huge, yeah. And by the time you were at Commodore, things had moved along in Europe when it comes to like emissions standpoint. But I have worked on plenty of these 64s that come from England and other places where there is no RF shielding at all, nothing soldered to the board. Like you don't see the traces of it being removed. And I'm just like, yeah, it wasn't, because at that time, probably in like 82, maybe they weren't required yet in Germany or in England. And that came, a year or two later.
Right.
But anyways, yeah.
They were, VDE was real strict. And part of it was to keep outside companies from selling into Germany. And I knew that from my instrumentation days. They would literally meet the plane at the airport, take your stuff and impound it, saying it's not even allowed in for, you don't have the right paperwork to bring it in to have it tested. Because it's at that point, it's untested hardware. You had to have the right paperwork just to get out of the airport.
Amazing. Yeah, like that's what a world. I mean, it's so funny. Things are so different now. I guess it's just so much easier to like work internationally like that than it was back then.
Yeah. Oh, this thing called the internet where I can design a PC board and send you a link and you can look at it.
And then we can have it manufactured and get it in a few days, and then
Right. And then I've got an oven. I do my own solder paste and my own surface mount and everything. I've seen you do surface mount disassembly and reassembly and stuff.
I am so bad at it. Like it's like my Achilles
Have you tried paste? I saw you hand solder one, but you built the mounds up. And that to me, I do the opposite. I actually go in with my solder braid and I flatten out the lands as perfectly flat as I can get them. But then I add paste to it. Yeah, we're way past an hour. Add paste to it, and then I use my hot air gun, and that's how I get a flat one.
I need to do that. I have some paste, and it's right here actually. Someone designed open source 4 megabyte 30 pin memory. And in here, I think is some of the templates and stuff, or for soldering. But anyways, I tried to use paste, and I think that is the way to go. Yeah, let's see what's in here. I think in here is those metal. No, that's a
yes, Osh, I got one of those.
Yeah, like it's okay. Yeah. There's a sticker somewhere in here. Everyone, there's here. This is it.
Solder paste spreader.
There, that's the. What, you put the paste and you squeegee it over, right? Is that how that works?
That's right. And so there's an art to how to squeegee.
So you use this card or whatever, and you like.
My son does my assembly, and he likes the card better than the actual assembly thing I have. Oh. And so think of it as toothpaste. You don't want to press it through because it'll squeeze out through the holes. And if when you go to lift the metal thing off, if it sticks, wipe it off with alcohol, start again. You want to just press it through, and it'll leave perfect outlines if you do it right. If it's all smeary, wipe it off, do it again, because you can do it as many times as you want.
Well, that you hit the nail on the head with what my problem was with that CPLD is. Yes, I left solder so it was mounded and it wasn't making
so it was wetted already. Yeah.
Yeah, you want to have it flatten and squish it down, right? And then you can add the paste. Yeah, I get it. Yeah.
Yeah. It's an art. Nothing's cooler than when you're using your air gun. I saw you had one. Then when it goes bloop, and it self-centers, you tap the board and it'll kind of squeegee around, a line around. Hey, so I saw you use a desoldering. Was that you? You have a blue and yellow desoldering?
Oh yeah, Hacko.
Is that a
Hacko something or other? Something. I don't know, I forgot what version this is. That was money well spent.
I was gonna say, how much did that cost?
I think this one was 300. Oh, here it is. It's a 301, Hacko 301.
Okay.
I recall it being like $380 or something pretty expensive, but
it's money well spent, first, especially doing what you do. And I've got a Aoye, whatever they're pronounced. I'm on my. Back in the day, a Pacer, I think it was, desoldering tool was like $3,000. That's more than I made in like a quarter of a year.
Wow.
Yeah.
Yeah. I mean,
so to have one at home is just amazing.
The first one I had was like a Chinese one. I forgot the model number. It looked like this. It was like a self-contained one.
Okay.
It worked, but it really didn't have a lot of suction. And people were like, get a Hacko 301, which is what does this, obviously. Yep. But, I made a video recently after reviewing one of those cheap oscilloscopes where I wanted to show people that it is possible to desolder from a board without damaging the board. And the way is, if you know the chip is bad, you cut the legs off, remove the body of the IC, and then one by one, you pull the chips out, the legs out.
Legs, yeah.
Right? And then you use solder braid or a solder pult kind of thing.
Right.
To clear the holes out. It's a lot more time consuming than this, but it's certainly a lot cheaper. But if you're taking off like several chips, like a whole bunch of RAM, that's really time consuming. So
and these PCBs of the old days, for the feed throughs, there's actually a small sleeve inserted sometimes.
Totally, it can pull out very easily.
You suck it. Yep, comes out. You look at your leads, and there's a piece of metal on there. It doesn't belong. You sucked out your feed through.
Sometimes what I do is, like, for really old boards, like over here I have a little stack of old PCBs they're kind of like junk ones that I get from e-waste or whatever, but I have good components on them, but nothing is socketed. So what I use is like a really high power heat gun, and I point it at the back of the board, heat the hell out of it, and I bang the board, and like the chips will fall out. but sometimes I have to pry them out, and then it will pull out those little via thingy-majiggy things you're talking about.
Right. Now I have an infrared one. I did a video for Hackaday about 6 years ago, and I actually showed my BGA polar, and it's an infrared. It's basically a halogen bulb, right, with lots of shielding for your eyes. And that will, you give that 20 minutes to where a drop of flux just turns into smoke. You can lift that right off the board. So you actually take aluminum foil and cut a hole in it, just the size of the chip you want. So all the rest is reflecting. So yeah, I even have a way to get the BGAs off. But I don't have an X-ray machine, so soldering BGAs is always iffy.
I stick to stuff from like the early 90s and then earlier, so I will never have to touch that stuff because I won't be able to do that properly.
Right.
My phone is blowing up for some reason. Okay, it's nothing.
Yeah, I was going to say, well, it's 20 minutes after the hour, so we've been talking for an hour and 20 minutes. Can you believe that?
We didn't even get to any of our topics.
Any of the topics? No. Yeah.
Wait, is this show supposed to be an hour or is it 2 hours? I don't even know.
It's an hour. It's at least an hour, and then we do what we just did, which is we just keep talking. So
okay. So
I can't believe. I mean, people listen for the entire. I mean, you see the chat channels just still going.
I apologize, everyone. I see lots of messages flying by, but we need.
It's so hard to pick them out. That's right.
Yeah. So maybe Bill will have to do like a part 2 or something. I don't know. And
I'm thinking that because you have next to you. Let's not talk about it now, but hold up your DTV. So Adrian had this on his show, and I know the story behind it. And so we wanted to talk about this today, but we're not going to.
No,
we'll leave it. Maybe we'll do a second show.
Yeah, totally. So yeah, I guess
very cool. So any questions you have, that have crossed your mind where you said, why the frack did Commodore do it this way? And if you can't think of them now, feel free to bang them off me. You just joined our Discord. By the way, join our Discord at Coriolis-effect.com. The hard part's knowing how to spell Coriolis. And join our Discord channel. Adrian has just joined our channel, and it may be available in there for questions and whatnot.
Yeah,
I'll give you your whole section.
It's funny. I am on Discord. I'm on several other servers and stuff, and I do have to admit that I get way less time to read Discord than I would like, and it's generally because I actually have a full-time job besides this retro.
So do I. Yeah.
So between making videos and I put 2 out a week, pretty much regularly.
That's a lot of production.
Yes. It is. And earlier before we started, everyone, Bill was talking about like how much time it really takes to make videos. And that is absolutely the case. Like I can often spend longer editing after the fact than I shoot. But the one thing I do differently than most other YouTubers in the space is I don't script anything. I literally just take the camera and put it on a tripod, which is over there right now, but it's the one I'm filming with here. And I'm like, hey, everyone, like I think about it like this seems cool. Let me just make a video about this. And that's sort of the way I operate. And I literally never have a script or any clue of how things are going to go. And there have been videos that I shoot and it totally is a disaster.
You never get it. You never get it fixed, for example. Right.
Like I don't mind showing my mistakes. I always show my mistakes. I will always show the failures because I think it's a good learning experience, especially if I can figure out what I did. But sometimes it's not even worth making a video of it. Like never goes anywhere. And I have to tell you one story that before we end this, really funny. And I was going to make a video on this. I was recapping. And people know I don't like to recap stuff, but this was like a Macintosh motherboard. I forgot which one.
And we have to. And I
SMD caps. Yeah, like it's for sure. They were all leaking area and they're destroying the board. So I was recapping it. And while I was recapping it, I was done. All the new SMD caps were installed. I was like, sweet, this looks, I cleaned it. I was like so excited. And then I realized at some point I had taken the soldering iron and I had stuck it in like the braid or whatever, the little, the copper thing to clean the tip. And a blob of solder, molten solder had fallen off into one of the SIM sockets. And it was a Mac that had like a video RAM socket. So it's like a weird, like a 62 pin or whatever, some weird high density SIM socket. And it melted itself into the plastic
Oh, wow.
And that was that. Like that motherboard was ruined. Like I spent an hour trying to dig it out, and it just
Right.
destroyed the
Right.
socket. And it wouldn't work without that socket. It was the video RAM, and it just so that happens to me. And now I'm always like, Adrian, be very careful to put the soldering iron away from, or put tape over the sim sockets, because you
Right.
do
Right.
not want solder in your sim sockets. It's a
Right.
bad day.
Well,
So,
and I commend that you film a troubleshooting process, because I never think to start to film. Actually, when I did my LCD, I did film turning it on, and then when it didn't work, I turned off the camera and went to work, right? Because why am I going to film something that won't be successful? Why am I going? I mean, that was my thought. Was this thing's broken? Why I gotta fix it? I'm not thinking about the filming part.
it's like, I think when you're working on something you think maybe never is going to work, like your LCD,
Right.
Commodore LCD, is like, when you do fix it, if you can fix it, that's where I get my slogan, which everyone knows: it freaking works. I can't believe it freaking works.
Freaking works.
I
Yeah.
am, because I genuinely am so amazed half
We're
the
as
time.
surprised as everybody else, right?
Yeah,
When
like
it
I'm
does,
like,
right?
what the hell? Like this thing I never expected to work, or I can't believe it. I mean, obviously I get more, I'm becoming more experienced at fixing things. So,
Right.
now I'm a little more sure. But even then, I'm working on an old monitor and like, I don't know what's wrong with it. I don't know crap about fixing these, really. I mean, so when I'm just plodding around in there and I'm like, okay, this seems to be the problem. And then all of a sudden I change one diode and I'm like, oh my God, it freaking works. Like
Yeah.
that feeling is really cool. And I genuinely feel that. So that is the one thing you get when you do set the camera up, even though you could always, what I do occasionally, Bill, is I'll voice over
You voice
later.
it over. Yeah.
Yeah, if I've done like, hours of just random
Right.
fooling
Right.
around. But generally, I kind of talk. My problem, everyone, is I talk too much sometimes. I have to cut out a lot. There's a lot of editing because there's a lot of like jibber jabber and me just
Right. Right.
blabbering on about nothing. So
Yeah. My Hackaday videos are supposed to be 5 to 8 minutes long, and I can't make one for under 20, 30 minutes anymore.
yeah,
I just cannot do it.
me too. Me too. Like the YouTube shorts. I'm trying to make a video that's a
Right.
minute
Right.
long.
Try to make, but how do you get across the whole point? To me, the topics I choose.
Exactly.
Yeah, I got way too much babbling to do to. So for me, it's when the processor starts. You talk about those aha moments, like your diode. For a processor to start, one of everything has to work, right? The ROM, the RAM, the data bus, the buffers, but I enjoy making a processor start, because I start with the reset line, then I look at the clock, then I go and I'll trigger on the reset line and I'll watch it fetch its first instruction. And I'll do that with the scope, right? A15, A14, A13. Yes, it's look, the ROM chip select, it's a whole methodical thinking. And then you get to the RAM and it breaks. Okay, it's the RAM, type thing. So yeah, I love waking up an old processor, because that was kind of my if I was anything, I was a CPU whisperer back in the old days. For getting that whole loop to work.
Well, I think like with that Southwest Technical PC that I was working on, it's from the 75 with this Motorola 6800. The
Right.
fact that that computer generally works perfectly still is just, it blows my mind that like something that was designed clearly in a,
Oh, it's just, yeah, somebody talking about somebody
yes.
having my problem.
Yeah, I mean, just the fact that these old things still work at all is pretty
It's amazing. It's amazing. Yeah.
Yep.
And so that's what drew me to your channel, was you dive in. You like I said, you dive right in, not afraid to fix. Now, since then, I've learned you have way more parts than I do. But yeah, to me, it was like, this is unfixable. And I saw you fixing them. I'm like, well, okay. Now my LCD is broken in. And so the update for everybody, if you've been watching my LCD thing, because the display went out while I was moving stuff later, we found out that a flat ribbon cable had delaminated. I put in a new ribbon cable, and then I found a single, it came on, but the display was blank, as if the serial shift register to the display is not working. Sure enough, a single wire wrap wire on the display itself, where it had been nicked 40 years ago by somebody stripping the wire wrap wire, broke.
Whoa.
And the LCD comes back on. I'm like, wow, but but in my mind, it's not much of a victory, because I know it's really broken inside. It's 40 years old. It has to be. It's just giving the appearance of starting to work, you know?
For now. Yeah, it works for now.
For now. So, hey, thank you so much for joining me, Adrian. I'm sorry Ben couldn't be here with us today. But this was fun, and I got to tell you, we got to do this again sometime. We got 190 people listening to us live right now.
That's awesome, and Bill, thank you again for inviting me. I'm very humbled to be talking to someone like you. It's like I'm just a guy with no knowledge of all this stuff. I just learned by doing. So I'm amazed that, you know, folks like you can watch my videos and get something out of it. That means
well, the Commodore ones are my favorite ones because
of course I know I have to balance the, like, you know, what am I going to make a video about? Because some people are like, oh, too many Commodore videos, do something else.
Right.
So I mix it up. But you know, I will, my fallback is let me fix another 64 because I have a pile of dead motherboards.
Right.
And it's always fun because they're
and there's a reason there's so many. We sold so many.
That's right.
So let's end the conversation with how we started, which is what's the best computer or whatnot. And what I'll say that's hopefully immutable is, well, the C64 was the most popular home computer. Right? Whether you think it's the best, whether your school had all those, yes, I understand. But we sold more. So if that's the metric, then we were the most popular home computer of the early 1980s. And I was raised to think that way. I'm a mass quantity engineer, you know. And once you become one of those, it ruins you forever. I don't know that I could go back to doing instrumentation, you know, after doing millions. So very cool.
Very cool.
Yep. So thank you for joining us again, and there's an invitation to rejoin us again anytime, Adrian.
Absolutely, and thanks everyone for watching and coming to see me. And yeah, thanks for watching my channel, and thanks for
Bill, plug your channel.
Thank you everyone. Yeah, I really appreciate it.
Very cool. So we'll see everybody here next week, and we don't even know what the topic will be, but we'll figure it out. So everybody have a good weekend. Be safe.
Yeah, be safe. Stay healthy, stay safe, and now I forgot what I always say. Oh, anyways, okay. Goodbye,
Take care, everyone.
Bye, Bill.